Hello, everyone. I'd like to welcome you to an overview of our new EMC lab that we opened in Etteinheim, Germany in 2021. And I have with me Spindler, who is not only running the lab now, but helped put it in place and get it designed. So welcome, Jan.
Thank you, Dean, for your introduction. Yeah. Yes, my name is Jan Spindler. I'm here responsible in Germany for the whole location and especially for the EMC lab. We built here in 2021, started the construction 2020, so roughly 14 months to have all running here and build it up. Yeah, so and I started MPS in 2019, so and with starting planning the whole project.
Yes. Great. Do you want to we can show some pictures and some start walking through some aspects that'll be interesting for customers that are interested in using our EMC facilities?
Yes, of course. Yeah. I can give you at first a good overview about our location in general, where we are. Our lab, our location is near in the southwest of Germany. That means we are the second location in Germany between Munich as a sales office. We are now in Etteinheim, which is close by to Freiburg, Basel, yeah, and we are close to Stuttgart as well, where all the automotive suppliers are located as well, yeah. And as you see, it's not only the EMC lab what we created and built it. It's also we have an office area, and we have also meeting rooms, seminar rooms for training internal and also our customers or distributors and partners, yeah, for regarding hardware engineering, EMC, yeah, and all our products as well. So
great. Yeah, it looks great.
The main thing of the whole project and the whole building is definitely our EMC lab, where we have at least 3 chambers, EMC chambers, and some working places for electrical and pulse testing. So we are not only focusing on our IC testing, we are also focusing on customer applications for different industries, automotive, consumer, household, and medical as well. So this was the reason why we want to have also a deep application support for customers. Yeah, as you see here on the slide, it's we have a 3-meter chamber for all kinds of bigger products, like for washing machines, industrial applications, so all what is bigger. Yeah. Then we have for the automotive industry, we have the CISPA 25 chamber, which is full compliance as well. What we can do here completely automotive testing in case of emission and immunity. We have a shielded chamber for different kinds of conducted testing and analysis. So everything where you need only the shielding, yeah, and then some 2 separate places, working places, where we can do electrical and pulse testing, where we don't need a shielded chamber. And it's also focusing on automotive and industrial. So we're completely separated. If we want to make a deep dive a little bit in our capabilities, what we can do in Etteinheim is here shown on this slide. We are focusing with the big chamber for the 3-meter testing, especially for immunity and emission testing, where we have a full compliance setup, where we can have a turntable inside and also antenna mast which can be moved from 1 meter to 4 meters height. So it's really full compliance regarding the actual standards like CISPA 11, CISPA 32, as well as the generic standards like the ESC standards. We can go up to 6 gigahertz in case of emission and immunity testing, and can handle equipment up to 1.5 tons with different settings for the power supply. So from DC up to AC, 400 volts, 125 amps. So really a wide range what we can handle here. If you look to the automotive chamber, this is 25, it's really up to state of the art as well. Also from up to 6 gigahertz for the immunity and the emission testing with 150 volts per meter. In some ranges, definitely more we can handle, like the radar pulses up to 600 volts per meter. Also full compliance setting. As mentioned before, in the shielded chamber, we're doing several tests where we don't need the absorbers, where we need only the shielding. It means we handle here all the BCI testing for the components, as well as handy transmitter testing, and for industrial consumer electronics, also conducted emission voltage meter testing. In this case. One of the area we definitely use quite often for our investigations and for our products as well is all about the pulse and electrical testing. So it's not only regarding EMI and the EMC testing. Here we have capabilities with amplifiers, with big power supplies to disturb the inputs of our power ICs to see if there is any reaction, if there is any abnormal function or something like this. Really quite often used. Very new we implement last year, 2022, is this area with the industrial pulse testing. As you see, we can go up to burst and surge, as well as the conducted disturbance of radio frequency fields as well, 4.6, and the immunity testing, voltage fluctuations and short interrupts, voltage dips. So all these kind of tests, and it's all a little bit related to our products, like the power stage of application. And we don't want to stop. For 2022, we want to continue and want to investigate as well in direction of the magnetic field testing.
Okay. Thanks for the overview. Do you want to call out any of what chambers are we seeing across the bottom here?
Yes. So here you get really a good overview about our laboratory. So we have around about 500 square meters. On the first picture, as you see, it is the big chamber with a height of 6.5 meters. And on the other side, all these rooms. And behind the big chamber is the small automotive. As you see below, you see both setups, which are quite different between the automotive on the left side and the industrial consumer on the right side, where we have on the one side a wooden table with a metal ground plane, and for the industrial testing you have a non-conductive table with the antenna in 3-meter distance. So this is really state of the art. One of our topics was the whole automatization of everything. So we have masts which can change the polarization automatically, Yeah, and as well on the left side you see one of our biggest investments in our equipment, the amplifiers for the immunity testing, so we can switch between automotive and industrial. Quite easy and all automatic.
Great. Do you want to talk through like what a typical day of when we have a customer coming in and you're working with them? Do you want just a simple overview of what typically happens?
Yeah. So at the moment, we are really focusing on flexibility. So that means the quite common way is a customer was in another lab or was in a wants to have a final measurement, and he gets a failure or bad result. Yeah, and this is the point where we come in to. For example, is really the customer calls us, has a problem, has a limit deviation or is above the limit, or has any problems with the immunity testing, and in this case we come he comes to us because we've tried to be very flexible in case of scheduling a time slot and helping him very fast. And means really the customer comes to us, we discuss the problem, we checking the results he has already already with him, yeah, and we analyze this and checking if we can reproduce these failures or these limit deviations as well, yeah. And as soon as we have this done here in our laboratory, then we checking for the investigations, yeah, on this and try to improve this. In parallel, we try really to have everything on site in case of components, inductors, capacitors to improve the whole product. Yeah. So a typical day is really one day where the customer is in our lab to get a better feeling and get maybe really a solution where he can continue his certification of the product. So
are you doing sounds like you might be doing some kind of rework testing too, where you have components and switching components out and doing some using experience you guys have with how to solve different problems?
Definitely, this is the main task we have is the rework on the problems. Yeah, so we have the experience based on our power products, which is definitely a noise source. Yeah,
Right.
and based on our experience on this, we help our customers or external customers to rework on their layout, on their design, and try to get a solution. Sometimes we can help by adding some components. Sometimes maybe we can not help in this case, and there needs to be a new layout to be done.
Yeah, yeah. Well, great. Well, thanks for the overview. And you know, we can have customers go to our website. We have a EMC Lab section of the website, and people can get more information, see some more videos. There is a contact form where you can fill out your application, information about your application, and someone from Jan's team or other locations will reach out to you quickly and help you get started.
Yeah, as Steve mentioned, EMI is important for all electronic products because of it's not only that it's required by our government to bring it on the market. It's only a functional aspect, and I think this is something I want to describe a little bit more in this discussion as well. That's not only a functional point or economic point. It's both, yeah, and it's not only doing because it's required. It's really something what is quality, yeah, in the end for your product. Yeah. In general, why is the EMI important in case of the functional point? It's really based in the last years. The environment is very rough. Yeah, so you have different kinds of radio frequency services. Yeah, you have Wi-Fi everywhere. You have LTE, 5G, and everything is around. And really, your device, your product needs to work under this rough conditions. Means your product needs to be robust in one direction, and also you need to reduce the emitting of noise and disturbance so that the environment don't get disturbed. Yeah, your radio, your smartphone, your Wi-Fi, and so on. And this is really one of the functional point of view you need to know. From the economic point of view, you cannot bring a product on the market without EMI testing. It means you really need to do it, yeah. And if you don't do it, you have the risk that you have a delay on your whole project, and then maybe also a problem in case of costs if your product needs to be redesigned because of the EMI topic. That's why you need really a good development process, which starts quite early in your product design and your product definition. Yeah, because all your pressure for your product and for your project is really is high. Case of high innovation, fulfilling the requirements, fast time to market, high reliability, and optimized cost, which makes the whole success of your company and all your products. That's why we as MPS also think about how can EMC become a successful factor for your design and for your project. And that's why we want to support our customers especially with the EMC Lab in Germany and the US and China as well, to get your project to success, yeah, and you get a fast time to market as well. For this, we try to help you with trainings to understand roots and the background of EMI. On the one side, on the other side, we will help you and support you in the beginning of your project, yeah, by doing pre-tests and evaluation of possible concepts and yeah. And additionally, we can support you by a clear, structured EMI, EMC development projects, where we can support by pre-compliance testing from the beginning of your first hardware sample up to the last sample. For this, there's really in the beginning several tasks you can think about and you need to think about. If you look to our power products, to our DC-DC switching regulators, for example, you have several possibilities how to set the switching frequency, but you need to have in your mind as well how this switching frequency affect your EMI behavior as well, and as well as which options you have as well, like frequency spread spectrum, shielding, input filters, and so on. So it means it's really a whole concept what is around all this DC-DC and power stage. For this, we support customers with our evaluation boards to get a first impression of our products and the performance of the products.
So are you, when you're doing that with customers, are you using the MPS evaluation boards and then simulating their their application, or how are you helping them out at that early stage?
Yeah, with our evaluation boards, we try to get to a design with a typical application from customer is. For sure, the possibilities we have with our evaluation boards, the most customers don't have it. But here with the evaluation board, we want to show some solutions, some key factors which are important for good design. Definitely. So we starting with our evaluation boards for our investigations and to find root cause of a good or if a bad EMI design. Yes.
So are they doing that typically even before they're doing layout?
Yes. So we try to figure out what are the layout requirements for the customers, and this is the goal of what we're doing there with our evaluation boards.
Yep.
Yeah. So because normally you as a customer has nothing else than this evaluation board in the beginning, yeah, to get an impression of it. So, but it's for sure an evaluation board needs to fulfill several requirements. It means on the one side the EMI testing, which is very hard, yeah, to fulfill, and the other side also the some possibilities and easy handling in case of all the electrical testing and evaluation, efficiency, step response, and so on. So it means at the moment our evaluation boards try to handle all of these topics, which is not easy, definitely. Yeah. What else do we, based on our evaluation boards and all our experience on this, we try to get really in the first layouts from the customers that we add additional filtering and possibilities for modifications. This is that's why evaluation board helps us in the beginning, because there we can place different capacitors, different inductors. So this is a little bit built up that we can add or delete some components to get to a certain layout or setup, which is in the customer applications. But when the customer is doing his first layout and first design, maybe we think about to have these options as well to figure out what is needed in the end or what is not needed. Yeah. For this, if your design or if your layout is don't have these possibilities, yeah, then it's really hard in the lab later with your sample to add components or add maybe additional modifications if you have not this possibility in the beginning, yeah, and then you really need much more time in the lab as well. To realize something like this, like a modification. Yeah.
So customers that do testing ahead of time using the evaluation products, they at least get some idea of the components and the layout needed. So they at least know where there's going to be some challenges ahead of time. And don't design a layout that is so tight or doesn't have any flexibility, where if you run into problems, you might have to step back and do some redesign.
Exactly.
Does that happen very often? Have you seen that?
It is always a topic. So really every kind of customer tries to optimize the design from the beginning, yeah, but you never know exactly where you get the problems, yeah. That's why maybe you need to get this, as you mentioned, you need to go one step back, yeah, and maybe do additional loop, yeah, to understand your design much better.
If someone wants to do that, typically, is that something that they can achieve in a day, a half a day? What's the typical? need?
And it's typically one day if you have one problem. If you one day is typically lab time in our lab to analyze the problems.
Yeah.
To be honest, not every time you find a solution after one day. It's depending on the complexity and as well as mentioned, how big is the modification and how difficult are modifications on the board to make. Sometimes you need 1 hour to do a modification, and that's quite.
But yeah, again, probably the overall concept that anyone that's done this for a while knows it's much easier to discover this and design these issues out on your evaluation hardware instead of your first actual board that you get, right?
Yes. Another big thing is really to plan your test session or your lab session. Is really something quite important to think about. What hardware you need, what you need to take with you in the EMC lab. One important thing, for example, which is quite often missing, is maybe to have a golden sample. You do a lot of changes over time, and it's good to have still one sample which you have always with you to compare results and to see if there is any improvement on this. Or so you have, because when you heavily modified boards, it's not always that it's getting better. Every time you modify something and you rebuild it as well, it's not sure that you get the initial result, because you do so much modification, soldering, destroying something, changing components. And that's why, for example, a golden sample is every time something which makes absolutely sense to see, to compare results, to see where you come from, and so on. This is something what's quite often missing. So you always.
Do you want to walk through how some best practices or how people should plan out to get the most out of their time in the lab?
Yeah, definitely. Let me say, we try to get the customer to discuss with him in the beginning about a test plan. What is the problem? What is your goal? Which standards you need? What is required in case of the standard? What interfaces do you have? So always thinking about your product to see what is all needed. Which connectors do you have? Which harness do you have? Which cables are missing? And so on. To have really a complete setup with you when you come to a lab. Because if you be in the lab and then you miss some cables or some connectors, and then you need to start to build these, to doing this test, you lose a lot of time. This is really one best practice. Really we go with the customer on the telephone in a video call all around the product to see, okay, is anything missing, to have like a checklist on this. And
so the people that are doing this most, let's say, with the least amount of challenges, what's the best practice for them? I'm assuming they write out their test plan. They write out every single thing they need to bring into the lab. Do you guys help out with that? Do you help out with at least get them started on what's a test plan?
We don't have a template at the moment. Okay. Regarding this, but we try to advise him with the questions, pushing with the right questions in a direction. The other thing is really is to have all the documents with you. That means you start with data sheets, with schematic, with layout. Often, if this is missing, you come to we're doing investigation, we're doing debugging. It means we need this as a base of the work. What we have, and you lose a lot of time if then it's on a server somewhere and you need to get these documents, then you need to print it out and so on. You lose time on doing this. So it's really, we advise, take everything what you have with you to the EMC lab to have it really about your PCB and about your design, and also to have spare parts with you, complete PCBs as well as maybe alternative components. For sure, we try to have a big pool of components here, but we cannot have every component what is needed, but we try to have the standard like different inductors from different companies here. We have capacitors here and so on. So that's why, but really think about to have in your mind some alternative components or some spare part components with you to save time and to get to the goal that maybe we have in the end of the day first result. Otherwise, we lose time. As well as getting preparing the whole hardware as well, your DOT with testing software, getting the software running, and so on, so that we don't lose time by installing software on the PC or something like this. So really that this is all prepared before you go to the lab.
Yep, that makes sense. If you're in a time-sensitive situation, right? Everybody wants to get everything done in one day, typically, right? They want to travel to the lab, get their tests all complete, and be done, right?
Definitely. So we really, it's like everywhere, the preparation is like a homework the customer needs to do. We help in case of asking questions, trying to get involved to this. And definitely, if we build up a little bit the relationship and the customer comes more often to our lab, you get a much better feeling to this. It's like if you do something more, then you get really a better feeling about the product. This helps as well. So maybe on this.
So we have a set of standard tests that we have listed these. These are listed on the website too, I'm sure, right?
Yes, so we have we are prepared for the basic testing methods in case of automotive and industrial consumer testing, definitely. So we can go for the emission testing. We start at 9 kilohertz and go up to 6 gigahertz, and as well for the immunity testing, where we start at depending on the test method, but we're starting at 100 kilohertz and go also up to 6 gigahertz to have the full range capability for the testing. And this is typically you find an overview on our webpage, and if there is something missing, please ask, get in contact with the team, and we will checking what is possible, because the whole range of all standards and all testing methods, it's very big. So it's and quite often we can help on this as well, or find some solutions where we can do definitely investigations or optimizations with maybe an alternate with a different test method to come to a goal. Because in the standard it's defined what you need to fulfill, but it's not defined how you get to this. Okay, we always talking a lot about emission testing when we're talking about our products, DC-DC converters. Right. It means I have, for example, this conducted emissions testing, because our switcher regulator is a noise source. Right. By definition, it's switching, and switching has noise or produce noise. I don't know if you know the background about this. What's the problem? maybe I can show you here. This is a picture here of the voltage measurement of the switch node. It means the rising edge. Yeah.
Yeah.
Normally, this is a time measurement. It means oscilloscope measurement. You see the voltage and the time.
Mm-hmm.
And what we doing in the EMI or EMC is we transfer this to frequency. So every signal is a sum of different sinus signals. So you can get the signal out of a lot of sinus signals. Yeah.
Mm-hmm.
That means and as it's faster the edge is. So it's if the edge is here, how can I draw here?
Yeah. So the top line, that's the voltage as the device switches on. Is that what we're looking at? Okay.
Here, switch node off.
Yep.
On. Yeah, and then it's on off on off. Yeah.
Okay. And so you have the bounce as it turns on. And what's the lower trace?
The lower trace here. This is This here is measured on another point. Yeah. This is a switch node. That means it is measured here.
I'm not seeing your cursor move or anything.
Wait.
Oh, there we go. Now I can see it. So there are two traces, right? One is the voltage step up, and then the lower, the blue. What's
the
that
lower
trace?
Blue is measured also the voltage at the you see in the picture below the big electrolytic cap. Yeah.
Okay.
And this is one topic we will present in several topics maybe this year. Is we have the problem now that this ringing, what you see on the switch node, means behind the IC, you can measure also in the input of the IC. Yeah. This is, let me say, if the switching is, you have this ringing on the switch, then you see it on the input as well. And this electrolytic capacitor, what you see in the here below this near field probe, that has an aluminium outside, and this outside acts then like an antenna. Yeah. And this
so you end up having the oscillation, and it just doesn't dampen out quick enough.
Yeah, exactly. So that then you have here this. Do you see my cursor now?
Yeah, I can. Yeah.
Then it means you have this ringing from the switch node to the V-in, yeah, and then you radiate this noise, this ringing here.
And that acts as an antenna, because it's not really an antenna, right? The purpose is not an antenna.
No, the purpose is not an antenna, but the problem is always a metallic trace is an antenna in case it's not a good antenna, but it could be a good antenna in a certain frequency range where it belongs. It's antenna is defined by, antenna is also defined by the length, and it's it is depending on which frequency you want to have or want to measure. That means middle wave in US, it's a big antenna. It's long antenna, for the middle wave. And for DAB, for example, you have a small antenna, because higher frequency, shorter higher wavelength, and then so on. So at
certain switching frequencies, then different parts of the board or even components could all of a sudden just start acting as an antenna and emit radiation. Okay.
Exactly. This is one topic what we have, because when we now increasing the switching frequency from maybe a few years ago, typically 400 kilohertz, something like this, you go now to 2.2 megahertz, for example, for automotive, then you get other problems than you had before. Then because with the higher frequency, other traces or other parts
Right.
on the PCB radiating. Yeah, so that really you get there other problems. And what we see here is what we don't see in the past so often is really that for example here this electrolytic capacitor acts like an antenna, because the housing is floating. It's not grounded, it's floating. Yeah.
Mm-hmm.
And then you have this ringing, and this is the other topic. When we increase, it's not a good marketing. Yeah, definitely. Yeah, if you look at this, that's why we need to think about how we make it, because this ringing is a high frequency noise. Yeah, in the frequency range. The best is to have very no ringing or very low ringing,
Right.
in case of voltage. And it means with this higher, with the new generations of our ICs, we see that maybe that's not perfect. So that means we need improvement, and we see problems which we didn't see before. Yeah, but we're looking for it's always challenging every time, challenging in case of higher efficiency, lower costs, and now we have the problem worst EMI. So
right.
that's meant you have always in Germany you have this quite often show this triangular. Yeah, we say
Right.
you can, if you do this, then you affect the other thing as well, and that's
Right.
that's a big topic where we are, and that's why EMI is never never getting uninteresting. Yeah?
Right.